In this video, we're going to go ahead and divide polynomials by linear expressions. So typically, the way we do this is with the long division process. There's two different ways to do this. This long division process here that we saw in the last one, or what you could do is you could use what's called synthetic division. And we're going to go ahead and go over synthetic division. That's the way the process we're going to use in this one is synthetic division, because it's much easier, much faster, especially when the polynomials get bigger, but it only works for nice linear factors, such as this, the two terms where there's a 1 in front of the x. Otherwise, it gets a little bit, more difficult to the point where it's like, why even use the synthetic division? But if you have a nice factor like this, like the x plus 3, it's going to work out nicely. Now, what's going on here with the plus k? If you end up with the remainder, you just put it over the divisor. We saw that in the last section. Unfortunately, I don't have any examples here for that. Really simple, though. I'll show you what to do at the end, if you were to have a remainder, what you would put. So here's how synthetic division works. We're going to look at our linear factor here, or our divisor, which is x plus 3. So we're going to put a box here, and in that box, we're going to put the opposite of this number here. So it's a negative 3. It's really what makes that 0. Negative 3, if you plug into the x, gives you a 0. So this is actually a root, technically. But it's always the opposite of that number. So then we're going to put 2, negative 1, negative 25, negative 12. I'll explain where I got those right now. So where did I get these numbers? Well, 2, negative 1, negative 25, and negative 12. So I got them from the numerator there. So how do we start this? Let's bring down the 2. Then we're going to do 2 times negative 3 is negative 6. We're going to add these up to get negative 7. Times negative 3 is positive 21. Add those up to get negative 4. Times negative 3 is positive 12. Add those up, you get a remainder of 0. Like I said, we'd end up with a remainder of 0. So this last number is the remainder. This one's the constant term. You could think of it as the x to the 0 term. This is the x term, x to the 1, x squared, and those powers will just keep going up and up and up. And it's kind of strange. You work from right to left. It's so much easier to work right to left on that one. So your answer is going to be 2x squared minus 7x minus 4. So just using this, 2x squared, negative 7x, and then negative 4. We don't need x to the 0. It's just saying that's the constant term. Now, what if we had a remainder? Let's just say this was 10. Then you would just put it over the divisor, that x plus 3. So we would just put plus 10 over x plus 3. That's if you end up with the remainder. That's what you would do with it. In our case, we didn't have a remainder. Okay, divide polynomials. So let's go ahead and go over this one. So we're going to divide this again. And this is the problem with synthetic division. The long division, that longer process I was showing you earlier, you won't make a mistake that you're going to see in here. Here's the mistake you could possibly make, though. So let's start with our box. So what's the opposite of negative 5 is positive 5. And then we're going to go ahead and list our coefficients. So we have 2, negative 11. And then this is the mistake. Notice that's x cubed, x squared. Where's our x term? If you don't notice that term missing, you're going to make the mistake on synthetic division and not even realize it. That's why it's so important. So 2x cubed minus 11x squared. You can picture, we'll put a placeholder of 0x in for the x term. Depending on whatever term's missing, it could be the x squared term, but if it should cover every single term in the polynomial. 3, 2, 1, 0, right? It should cover all of those. So I'm going to put that 0 there, and then the 25. And then we're going to write right through that synthetic division. So bring down the 2 times 5 is 10. Negative 1 times 5 is negative 5. Negative 5 times 5 is negative 25. Gives us, once again, a remainder of 0. So this is our remainder, our constant term, our x squared term. So your answer is going to be 2x squared minus x minus 5. And that's the idea of this assignment. Should be pretty simple using that synthetic division. If you didn't quite get it, just keep replaying the video till you get the process done.